Good morning, everyone. Myself, Dr. Balaji Maram, working as a professor, SR University, Warangal, Telangana, India. Today, we will discuss about some of the concepts related to signals and how to handle signals in Linux programming. Linux or Unix programming. Here, introduction to signals in Linux. In Linux operating system, signals are fundamental inter-process communication mechanism used to notify a process that a specific event has occurred. Okay. Suppose when some processes are under execution, if normally or abnormally, if the process is terminated or something happened to the process, so automatically the kernel takes the responsibility to generate some set of signals. Okay, so based on the signals, either other process or user can understand what was happened with the current process, why it is terminated. So it is possible through signal concept in Linux or Unix operating system. A signal is an asynchronous notification sent to a process or a group of process to trigger a predefined action such as termination, suspension, continuation, or execution of a user-defined handler. Suppose some function is there, that function is under execution because of some internal factor or external factor, that is stopped or terminated or paused. Okay, in such scenario, the kernel generates some signals. Signals plays a critical role in process control, error handling, resource management, and system monitoring. Unlike regular function calls, signals can interpret a process at any point during its execution, making them lightweight but powerful tools for system programming. What are the reasons for signal generation? Typical events that generate signals include division by 0. Suppose some formula is there, A is equal to B by 0. So that is division by 0. That is not acceptable. That is invalid. Next, invalid memory access. Suppose invalid memory access for memory space is defined from valid point to another valid point. If out of the bound means automatically that is invalid memory access. Next, user pressing control C. Suppose some process is under execution and when the user press the button control plus C. Next, termination request from another process. Suppose both are executing parallelly. Suppose a client what is that, parent and child. So when the parent wants to terminate the child process, so in such scenario, termination request from another process. Okay. Next one, child process termination. So by default, the child is terminated after its execution. So that is, so in these scenarios, the kernel generates signals. Signals are deeply integrated into Linux or Unix philosophy. Okay. Signal concepts. Asynchronous nature. So here signals are asynchronous, meaning they can occur at any time independent of the process current execution flow. When the signal arrives, the kernel temporarily suspends the normal execution of a process and deliver the signal. Okay. Suppose some process is under execution, and when the process receives a signal, so automatically the kernel gives that signal to the process, but temporarily it suspends the normal execution and delivers the signal. Okay, means sometimes the signals are very valuable for those processes. So that is the reason whenever it receives a signal, the kernel immediately delivers the signal to the concerned process only. Then the process takes care whether it is it needs to take care about that signal, or it can ignore the signal, okay, or it can execute the default uh, code, okay. So here, signal delivery. Signal delivery involves three steps. First one is signal generation. An event causes a signal to be created. Okay, generation means an event causes a signal to be created. Signal delivery. The kernel delivers the signal to the target process. Next, signal handling. The process takes action based on the signal's disposition. Okay. These are three different points related to a signal. Signal disposition. Each signal has a default action. Suppose when there is a signal, the default action will be predefined. Okay? Otherwise, the process can take the step when it receives some signal from some other process or some kernel. Okay. So here, what are the default actions? Terminate the process, terminate and dump core, stop the process, continue a stopped process, and ignore the signal. Okay. So here process can modify signal behavior using signal handler. So already I told this is default action will be taken care by the kernel. Okay. But in other cases, the process takes the responsibility to change the default behavior by executing its own signal handlers. Means those are nothing but functions. Okay. Okay. So that is about signal actions. So signal life cycle in Linux. A signal is generated whether it could be from hardware signal or software signal or user event signal. Whatever it may be, a signal will be generated. Second one, the signal marks the signal the kernel marks the signal as pending. So when the signal is generated, that is nothing but pending state. Okay. Next, if the signal is blocked, it waits. Okay. If the signal is blocked, it waits until unblocking. Okay. So when unblocked, the signal is delivered. Okay. When it is unblocked, the signal is delivered. Next, the process executes the default action or user defined action or ignore the signal. Here three cases will be there. When a process receives a signal, maybe the default action will be executed, that is first case. Second case, user defined action will be executed. Third case, ignore the signal. Means no need to take any action, listen and ignore, that's it. This mechanism allows Linux to effectively handle unexpected events. Okay, so maybe not all signals are equal. Some signals are very sensitive, some signals are very lightweight. So lightweight signals we can ignore, but sensitive signals means we need to take care and we need to check, we need to take care and we need to execute the proper code. Okay. This is the standard signals. These are the standard signals from Unix or Linux operating system. Here signal name, number, description, default action. So here first one SHINT. The number is 2 and interrupt. Okay, it indicates some interrupt from keyboard. That is nothing but control plus C. Suppose some code is under execution and that code is like infinite loop. So in such scenario, at some point we need to terminate from infinite loop. So for this purpose, we need to press Ctrl plus C. So automatically the process will be terminated and it will exit from control loop. So what about default action? Default action is termination only. Okay, termination. Control plus C means termination only. Second one, sig term. Signal means termination request. Okay. Suppose some process is going on and when it sends some termination request, automatically SAGTERM will be generated and the number is 15. The number is 15 and termination request. So the default action is terminate. Next, sig kill. SAGKILL and number is 9. Okay, so when it will be generated, it will be generated when the kill function, kill system call will be executing and it generates SAGKILL and it cannot be caught. It cannot be caught, and by default the process will be terminated. Next one, SIG stop. Okay, so when a process tries to stop another process, so that is SIG STOP and its number is 19, then default action is stop. That process will be stopped. Next, SIG CONT, continue the stopped process. Suppose already the process is stopped and when other process wants to reactivate, that is like continue the process, continue the stopped process. So SAGCONT and number is 18 and the default action is continue. Okay. Next one, SEGV segmentation fault. Okay, segmentation fault, that is like some external factor, that is core dump and number is 11. Next one is SIGCHLD, child process terminated. Child process is after execution, the child process is terminated. In such scenario, it generates one signal SIGCHLD and number is 17. Okay, the default action is ignore. That is general termination. Next, SIG alarm. Its number is 14 and alarm clock signal. Suppose some alarm is generated, so automatically SIGALRM will be created and the default action is terminate. Next, SIGUSR1. Okay, and its number is 10. It is user defined signal 1. Second one is SIGUSR2 and its number is 12, user defined signal 2. In both cases, the default action is terminate. Okay. Here, signal handling in Linux. Here, how to handle the signal? Okay, signal handling allows a process to intercept the signals and execute custom code instead of default behavior. So here already I told, when there is a signal, the signal can be handled, can be ignored. That is our wish. So here, how to handle the signals? Here in older versions, the signal function name is that is signal. Okay, but in latest versions, that is like POSIX complaint system call is that is sigaction. Okay, both are same, but only versions are different. Yeah. What about signal system call general form? Okay, so here void star signal. First one is SIG NUM signal number. Second one is handler. Handler means user defined function. The signal is generated by the user, OS or another process. In three categories, the signal will be generated. It could be from user, it could be from OS, it could be from another process. Okay. It is delivered to the target process. suppose P1 generates a signal and that will be delivered to P2, process 2. Okay. The process handles it by default action, ignore and catch it with a signal handler. Default actions of a signal. Suppose what are the default actions? Terminate the process, ignore the signal, stop the process, continue the process, generate a code dump. These are the things. And what are the constants? SAGINT means terminate a program. Okay. Suppose some infinite loop is under execution, and when we want to exit from the loop, then we need to press control plus C, then SAGINT will be generated. Second one, SAGKILL, forcefully terminate a program. Suppose some process is under execution but another process wants to terminate the process, kill the process, then SAGKILL. Next one, SAG stop, suspends the program. Okay. This is the code. A simple example, the header files are hash include stdio.h, hash include signal.h, hash include unistd.h. Here printf, just one signal handler is there, some function, user defined function is there. Its name is void handle underscore SAGINT, that is the function name, and within bracket one argument is there as int SAG. So here SAGINT received and its signal number is percentage %d comma SAG. Next, main function int main begin signal of what is the signal constant SAGINT. If it receives SAGINT, the corresponding function will be executed, that is second argument handle underscore SAGINT. Okay, so that is signal is ready. So when it receives anything, automatically the user defined function will be executed. Okay, now while one means always true, that is like infinite loop. Okay, begin. Next, printf running, it is running. Next, it gives some message like press control plus C for exit. Okay, then sleep of 2. After 2 seconds it prints the same message, after 2 seconds it prints some same message, and so on until we press control plus C. So when the user press control plus C, automatically the signal system call receives SAGINT, and when it receives SAGINT, automatically it executes the user defined function handle underscore SAGINT. Okay, this is about this example. Next, sigaction. Already you have observed signal is a system call which was available with older versions of Unix or Linux. Now in latest versions it supports this system call only, SAG action, advanced signal handling. SAG action is a system call in Linux used to examine and change action associated with a specific signal. It is more powerful and reliable. It provides better control and portability. Okay, this is about SIG action. Now what about syntax? The written type is int only, SIG action, begin, signal number, comma, constant, struct SAG action means star act, that is a pointer, comma, struct sig action means pointer old action. Okay, so here what about signum? Signum means that is signal number. Already you have observed in previous slides, for every signal constant you can find one signal number. Okay, that is nothing but the first argument sig number, like 2, 4, some 11, different numbers are there. Next one is ACT. What about ACT? It is a pointer. It is pointer to a new action for the signal. Pointer to new action for the signal. Next, what about pointer old act? Pointer to store previous action. Pointer to store previous action. Okay. Next, what about example? Hash include stdio.h, hash include signal.h, hash include unistd.h. Here, user defined function signal handler function, and the function name is void handler. Handler is the function name, and the argument is int signum printf signal percentage %d is received, that is signum. Okay, that is user defined function. Next one is int main begin struct sigaction sa, that is means predefined function only, predefined structure only, struct sigaction sa. Okay, so here first of all we need to assign the handler function. Sa dot sa underscore handler is equal to handler. Next, sig empty set. Okay, here ampersand sa dot sa underscore mask. Here what is the meaning? No extra signals blocked. Okay, no extra signals are blocked. Okay, now what about flag? No special flags are here, so by default it is 0. Sa dot sa underscore flags is equal to 0. Next, register handler for saj, and first of all we need to like map between saj int and that handler. Now what about function name? Sig action bracket the signal name saj int comma, and the built-in structure name, that is ampersand sa comma null. So automatically the SHINT is binds with the handler ampersand SA. Okay. Next, printf, press Ctrl plus C to send SHINT. Now here first of all we need to create one infinite loop. While one begin printf process is running. Okay, while one means the process is running, it prints the same message again and again. But here we have given sleep, so that is the reason after every 2 seconds it prints the same message. Process is running like that. Then when the process is under execution, that is nothing but infinite loop. So when it is a infinite loop, automatically we are pressing Ctrl plus C for termination. So when we press Ctrl plus C, the kernel generates a new signal, that is SHINT, and the kernel delivers the signal SHINT to the concerned process. Okay. Then when sig action receives SHINT, automatically the signal handler means user defined function will be executed, that is void means handler int signum, and here the user defined function has only one printf statement, that is printf signal percentage %d received. What about output? Here when we press Ctrl plus C, it generates SHINT, but here it is running, and signal to received, then running, signal to received, and so on. Okay, this is the output. What about flags? Already you have observed one of the argument is SA underscore flags, means one of the field name in built-in structure. So what about flags? SA underscore restart. Restart interrupted system calls automatically. Okay. Restart interrupted system calls automatically. Suppose some system calls are suspended. So in such scenario, it simply restarts those system calls automatically. Next one, SC underscore SIZ info. Use extended handlers with extra information. Next, SC underscore no CLD wait. Okay, prevent zombie process. Means that is what is the meaning, like if any child process is there, but when the parent process is not able to handle the termination of a child process in such scenario, when we use this flag, automatically it takes care about the terminated child process. So, means what about consequence? The consequence is it prevents the creation of a zombie process. Okay. Next one, SC underscore no differ. Okay. Do not block signal while handling it. Do not block signal while handling it. Suppose earlier we have discussed about signal means creation, signal handling, signal termination, and so on. So when signal is created, but the process is like blocks the signal in such scenario, the signal will not be delivered to the target process. So at that time, the signal should wait. Okay, but when the process is ready to take signals, then automatically the newly generated signal will be delivered to the target process. So that is a regular one. But here, do not block signal while handling it. So when we give the flag SC underscore no defer, automatically the blocked signal means uh, do not blocks the signals. When it generated, automatically it will be delivered to the target process. Next, SC underscore reset hand. Reset handler to default the first signal. Okay. Kill system call. Here already we have discussed about kill miss command. The kill command simply kills the given process ID. Okay. The kill system call is used to send a signal to another process or process group. The syntax is int, that is return type is integer, function name is kill, and the first argument is PID, second argument is signal. What is the meaning of PID? First argument. PID greater than 0 means that is specific process. When it is 0, same process group. When it is -1, all process. Okay, that is the meaning of first argument. What about example? Hash include stdio.h, hash include signal.h, hash include unistd.h, int main PID, PID underscore t, PID, printf enter PID to terminate which PID you want to terminate, and here scanf is there. We need it takes the PID from the user, and if kill of PID comma sick term is equal to 0, sick term sent successfully, that is in child process miss when it kills the process, and automatically sick term will be generated, and the sick term sent successfully, else some error is there. Because of some error, the kill will not be the kill has not been executed. So p error of kill, return 0. What about input and output? Enter PID to terminate. Here we have given 4321. So if it is successful, automatically SAG term sent successfully. Okay. Raise function. The raise system call sends a signal to the calling function, calling process itself. Okay. So here, what about the general form? Return type is integer. Raise is system call. One and only argument, that is int sig. Okay. What about example? Hash include stdio.h, hash include signal.h. Here user defined function void handler into sig printf signal %d received via raise system call, and main signal of SAG USR1 handler printf raising SAG USR1 raise SAG USR1. Here we are responsible to raise that system call, and return 0. What about output? Output is rising SAG USR1 signal 10 received via rise rise system call. Sick child. SHGCHLD is a signal sent to parent process when child process terminates and the child process stops and the child process resumes. Okay, it mainly used to avoid zombie process creation, perform cleanup using wait and wait PID system call. This is the miss example. The output. Thank you.